Hello and welcome to Ot Math. In this edition of Ot Math, we are going to generate a quadratic equation or function based on 2 points. All right, so we're going to give 3 examples here. All right, so I'm given the maximum value g of -1 is equal to 6 and g of -3 is equal to 4. So I know that the parabola opens down. I know the maximum value is -1, -6. And this is the maximum value is the vertex. So I'm going to use vertex form. Y is equal to a times x minus h squared plus k, and I'm going to substitute these values -1 and 6 in, and I end up with y is equal to a times x plus 1 plus 6, right? All right, so now I'm going to use the second point. So I started with the vertex form first. I have to figure out a. I'm going to use the second point, -3 is equal to 4. I'm going to substitute in 4 for y and -3 for x, and I'm going to solve for a. So 4 is equal to a, so I have the 4 here, which is y, and -3 was the input, which is x, and I'm going to solve for a. 4 is equal to a times -2 squared plus 6. I'm going to subtract 6 from both sides. -2 is equal to a times 4. Divide both sides by 4. -2 over 4 is equal to a. A is equal to -1/2. And then I'm going to substitute that value back in, and I solved. Okay, next we have a similar problem. Minimum value f of 3 is equal to -5. F of 1 is equal to 2. Again, so we're going to go to vertex form, and we don't always have to start with vertex form. It could be intercept form, and in fact, the next problem is going to we're going to do just that. So we don't always, again, have to start with vertex form. It's just we're given the vertex here. So it makes sense to start with the vertex form. Of course, 3 is the input x here, -5 for k. So I'm going to write in these values here into vertex form. And then I'm going to take the second point and I'm going to solve for a again. So 2, this value 2 is equal to a times x 1 minus 3 squared minus 5. 1 minus 3 is -2. -2 squared is 4. I'm going to add 5 to both sides. I get 7. So now I have 7 is equal to a times 4. And a ends up being equal to 7/4. So I'm going to take that value for 7/4. I'm going to substitute it back into my function, and I've just created my equation for the quadratic. Okay, last one. I have a parabola that's tangent to the x-axis at 4, 0, and the y-intercept is 0, 6. So we know that this is a graph where my parabola faces up because the y-intercept is positive, and the vertex touches at one point. All right, so in this case, we're going to use the intercept form. And I have intercept form x minus 4, x minus 4. So when you have just one point, even though there's one x-intercept, there are 2 values here, 2, let's say, monomials that are going to be, 2 binomials that are going to be squared. And the binomials are the same, x minus 4, x minus 4. These don't have to be different. So y is equal to a times x minus 4 squared. Now we're going to solve for a. We have 0, 6 here. So we're going to substitute 0 in for x, 6 in for y. So 0 in for x and 6 in for y. And we're going to solve for a. So a times -4 times -4 is 16. 6 is equal to a times 16. A is equal to 6 divided by 16, or 3/13. And then we're going to use 3/13 to substitute that back in for a. And we're going to end up with, let me write the equation here. Y is equal to 3, should be 3/8. 3/8 times x minus 4 squared. All right, and you can leave it in this form. That's fine. That's it for this edition of Ot Math. Thank you for joining us as we derive equations for parabolas based on 2 points.